Five terrifying planets you don't want to visit. Number 5. Carbon planet. Our planet maintains a high ratio of oxygen to carbon. Carbon actually makes up only about 0.1% of Earth's bulk, hence the scarcity of carbon-based materials like fossil fuels and diamonds. Near the center of our galaxy, however, where carbon is more plentiful than oxygen, planet formation is very different. It is here that you find what cosmologists call carbon planets. The morning sky on a carbon world would be anything but crystal clear and blue. Picture yellow haze with black clouds of soot. As you descend farther down into the atmosphere, you find seas made of compounds like crude oil and tar. The surface of the planet bubbles with foul-smelling methane pits and black ooze. The weather forecast doesn't look good either. It's raining gasoline and asphalt. No smoking. But there would be an upside to this oil well hell. You may have guessed it. Where carbon is plentiful, you also find high quantities of diamond. Number 4. Neptune. On Neptune, one can find constant jet stream winds that whip around the planet at terrifying speeds. Neptune's jet stream winds push frozen clouds of natural gas past the north edge of the planet's great dark spot, an Earth-size hurricane, at a staggering 1,500 miles per hour. That is more than double the speed needed to break the sound barrier. Such wind forces are clearly beyond what a human could withstand. A person who happened to find himself on Neptune would most likely be ripped apart and lost forever in these violent and perpetual wind currents. It remains a mystery as to how it gets the energy to drive the fastest planetary winds seen in the solar system, despite it being so far from the Sun, at times farther from the Sun than Pluto, and having relatively weak internal heat. Number 3. 51 Pegasi b. Nicknamed Bellerophon, in honor of the Greek hero who tamed the winged horse Pegasus, this gas giant is over 150 times as massive as Earth and made mostly of hydrogen and helium. The problem is that Bellerophon roasts in the light of its star at over 1800 degrees Fahrenheit. Bellerophon's star is over 100 times closer to it than the Sun is to Earth. For one thing, this heat creates an extremely windy atmosphere. As the hot air rises, cool air rushes down to replace it, creating 1,000 km/h winds. The heat also ensures that no water vapor exists. However, that does not mean there is no rain. This leads us to Bellerophon's main quirk. Such intense heat enables the iron composing the planet to be vaporized. As the vapor rises, it forms iron vapor clouds, similar in concept to water vapor clouds here on Earth. The difference, though, is that these clouds will then proceed to rain a relentless fury of molten iron down upon the planet. Don't forget your umbrella. Number 2. Corioxo 3b. The densest and most massive exoplanet to date is a world known as Corioxo 3b. It is about the size of Jupiter, but 20 times that planet's mass. This makes Corioxo 3b about twice as dense as lead. The degree of pressure put upon a human walking the surface of such a planet would be insurmountable. With a mass 20 times that of Jupiter, a human would weigh almost 50 times what they weigh on Earth. That means that a 180-pound man on Earth would weigh 9,000 pounds. That amount of stress would crush a human being's skeletal system almost instantly. It would be the equivalent of an elephant sitting on your chest. Number 1. Mars. On Mars, a dust storm can develop in a matter of hours and envelope the entire planet within a few days. They are the largest and most violent dust storms in our solar system. The Martian dust vortices tower over their earthly counterparts, reaching the height of Mount Everest with winds in excess of 300 km/h. After developing, it can take months for a dust storm on Mars to completely expend itself. Hellas Basin is the deepest impact crater in the solar system. The temperatures at the bottom of the crater can be 10 degrees warmer than on the surface, and the crater is deeply filled with dust. The difference in temperature fuels wind action that picks up the dust, then the storm emerges from the basin.